Good morning, students. Let's begin our new lesson. In this lesson, we will continue to learn integer program model. And we know in last lessons, we have learned how to set up an integer program and typically to set up a binary integer program. And in these lessons, we focus on section 3, binary program model to set up. We now present a series of examples that illustrate a variety of formulation techniques with binary variables, including those discussed in the preceding two sections. For the sake of clarity, these examples have been kept very small. In actual applications, this formulation typically would be just a small part of a vastly larger model. Example 1. Making choice when decision variable continues. The research and the development division of manufacturing company has developed 3 possible new products. And we note in this table, this is 2 plants, plant 1 and plant 2 can produce the product. Product is 1, 2, 3, and the 2 plant available house is 13 house per week, 14 house per week. And the last row of this table is unit profit each product, sales potential of each product. The goal in this program is to determine number of units of each product so as to maximize the total profit. So we analyze this program. To set up this program, we need 2 decision variable. And in this program, we set the decision variable is x1 means product 1 produced, x2, x3 is 3 product produced amount. So if we think no other rejections, we can formulate it as a LP program. The objective function is use this unit profit times decision variables, and constraint is 2 plants available house limited, and we write as this 2 constraints. And the sales potential of each product is we write as these 3 inequality. So this is LP program, but in this program, however, to avoid undue diversification of the company product line, management has imposed the following restrictions. Restriction 1. From the 3 new products, at most 2 should be chosen to be produced. Restriction 2. Just one of 2 plants. Just one of 2 plants such be chosen to produce the new products. This is the 2 constraints emphasis on this program. So we think about how to express these 2 restrictions. Now we think about restriction 1. From the 3 possible new products, at most should be chosen to produce. That is, in these 3 products, we only choose 2 to produce. We want to express these restrictions. We set decision variables yi. Yi is 0 and 1 and is binary variable. And if yi equals 0, the xi or product I is not produced. If yi equal to 1, then xi can equal to greater than 0, and means xi can be produced. So we express the content as this content, and we noticed this inequality express only 2 in 3 products produced, and we simplified this content as please choose 6 inequality to this 3 inequality, and we can simplify this. Now we think about restriction 2. Just one of the 2 plants should be chosen to produce the new products. Means in these 2 plants, only one to be chosen to produce. That is, these 2 plants is replaced. So we express the content as subject 2, 3x1 plus 4x2 plus 2x3 less than 13 plus y4 y4 variable is binary variable 0 or 1. And we notice that in this content, when y4 is 0, this content is holder, and the second content is not holder. When y4 equal to 1, then content, the first content is not holder, the second content is holder. So we realize choose 1 in 2. Choose 1 in 2. So we summarize the model of this problem is this model, and simplified it as a simplified model. And we noticed in this model, x1, x2, x3 is real number, and y1, 2, 3, 4 is binary variables. So it is a mixed integral program. This is the example 1. Now we introduce example 2, violating proportionality. A corporation is developing its marketing plans for next year's new products. For 3 of these products, it considering purchased a total of 5 TV spots for commercial on national television networks. The problem we will focus is how to allocate the 5 spots to these 3 products with a maximize of 3 spots. And the information is listed in this table. We notice in this table, this column is the TV spots 0, 1, 2, 3, and this is the product. And each product can purchase 1 TV spots, purchase 2 TV spots, purchase 3 TV spots. And we notice the profit of each product is not proportionality to the amount of TV spots. For example, product 1 purchase or use 1 TV spots, maybe reduced 1 million of profits. If you purchase 2 TV spots, it will produce 3 million of profits. So it is not proportionality to the amount of TV spots. The objective is to allocate 5 spots to the products so as to maximize the total profits. So in this program, we set up the model of these questions. We noticed that the product problem is not proportional to the amount of TV spots, and it is violate proportionality. Therefore, we cannot write a linear objective function in terms of this 个 decision variables. So in these problems, we set a binary variable yij equal to 1 if xi equal to g, otherwise 0. And that is y11 is product 1 purchase 1 TV spot. Y12 means product 1 purchase 2 TV spots, and Y31 means product 1 purchase 3 TV spots. So there are 9 binary variables. Binary variables in this table or in this program. So we can write a linear objective function as maximum j equal to y11 plus y12 plus y13 and plus 2 y22 plus 3 y23 and so on. That is the objective function, and we see it is a linear function. And we notice in these examples, the constraint is for each product y11, y12, y13, each product maybe only purchase one TV spot or 2 TV spots or 3 TV spots. So we write as y11 plus y12 plus y13 less than or equal to 1. That is only 1 is equal to 1. And the product 2 is y12, y22, y23. And that is less than equal to 1. And the production 2 can only purchase this 1 TV spot. And that is product 3. And the total TV spots is only 5 TV spots. So we sum this equal to 5. So the last functional constraint ensure that x1 means x1, 2, x3 means if we set x is the purchase TV spots in product 1, product 2, and product 3. So this is the model of these programs, and we noticed all decision variables is binary variable. So this model is a BIP model. That's these examples. Now we see another example, example 3, covering all characteristics. Airline needs to assign 2 crew to cover all its upcoming flights. We will focus on the problem assigning 3 crews. Based in San Francisco, 2 flights listed in the first column of the following table. The following table, we noticed that this is a flight, and we total is 11 flights. And this is the feasible sequence of flights. And there are 12 feasible sequence of flights. Exactly 3 of the sequences need to be, only 3 sequences need to be chosen on such a way that where the flight is covered. It is impossible to have more than 1 crew on a flight, where the actual crews would fly as passengers. But union contracts require that actual crews still be paid for their time as if they were working the cost of assigning a clue to a particular sequence flights in the bottom row of the table. The objective of this program is to maximize the total cost of the 3 clue assignments that cover all the flights. That is, we must realize these all flights, and the feasible sequence flight is only 3. It's only 3. So we set the decision variable is xj equal 1 if sequence j is assigned to a clue, xj equal to 0 otherwise. So we can write the objective function is the minimized total cost is x1, x2, x3, x4, and x2. And x2. So we use this low cost to times all decision variables. It is the objective function minimum j. Step 3. We think about the constraint in this problem. In this problem, the constraint is any flight of this clue must be finished. So we, for example, this flight, x1 can realize, x4 can realize, x7 can realize, x10 can realize. So we write as x1 plus x4 plus x7 and plus x10 greater than 1 means this flight must to finished. And similar to the second flight. Second flight is x2, x5, x8, x11 and sum it greater than or equal to 1. And the third flight is x3, x6, x9, and x12 can realize. So we summarize it and greater than or equal to 1, and so on. And this number is the order 2 flights. We noticed, for example, in flight 12, in feasible sequence of flight 12, first 2, 3, 4, and 5. And we noticed 8 feasible flights is first 2, 3, and 4. So all this number is the flight order. First flight, 2 flight, 3 flight, and 4 flight, and so on. So we summarize the model of this problem is this model, and this model is more complex or more larger. And we noticed that in this model, all decision variables is binary variable 2. So this model is BIP model 2. And the last constraint, sum all xj equal to 3 means only 3 clues to used. Okay, in this lesson, we have introduced some typical examples to set up a model by binary variables. So we noticed that binary variables is very important to set up integer programs. Thank you very much.